Today we'll get to know about differences. The first class and first video I have shown you what is interpolation, right? So interpolation with uniform spacing. What we are doing is uniform spacing. So we'll have the x and y values. So the value, the difference, the step value I'm taking as h. If I take the step value as h, then if I take the step value as h, then what will I have? The points will be, the general one will be xi equal to x naught plus ih, where I is changing from 0, 1, 2, 3, so on. So the points will be, if you put I equal to 0, you will get x naught equal to x naught only, x naught. Then if you put I equal to 1, you will get x1. What is x1? x1 equal to x naught plus h. x2 will be x naught plus 2h. x3 will be x naught plus 3h. Similarly, you can find out all the values till n. Right? So, this will be the equally spaced x values. Fine. Now, what is finite differences? Here we define three differences basically: forward, backward, and central differences for the function y equal to f of x, where the independent variable x is equally spaced. Fine. Now, first we'll get to know about forward difference. Right? What is forward difference? If we consider the function y equal to f of x of an independent variable x, right? So what will be the values for x? Just now we discussed, those will be x naught, x1, x2, so on. No? What the corresponding y values I'm taking as, let y naught, y1, y2, so on, y general term I'm taking yr, be the values of y corresponding to which values? Corresponding to the values. What were the values? x naught, x1, x2, so on, xr of x respectively. Fine. These are my x naughts and y naught values, xi's and yi's values. Now, the differences of y's. The differences, DIFF differences, y1 minus y0. See carefully what I am doing. I am subtracting second term minus first term. Similarly, next I will get it as third term minus second term, that is y2 minus y1. Next value is fourth term, that is y3 minus previous term, that is y2, and so on. These differences are called first forward differences of y. Right? These are the first forward differences of y. How are they represented? They are represented as, see here, this is called forward delta. First term is represented as forward delta y0. Second, you have y1 minus y2, subtraction of two terms. I'm taking notation for the right hand term, that is second term. Every time you will take the notation for the right hand term. That means first term is represented as forward delta y0. Second term is represented as forward delta y1. Next term is represented as forward delta y2, and so on. Right? So how we'll get? That is nothing but, what is forward delta y0? It is y1 minus y0. Fine. Next, what will be forward delta y1? That will be y2 minus y1. What is forward delta y2? That is y3 minus y2. Right? So on, if I write the general term for r, what will I get? So on, forward delta yr will be next term, one term here more, yr plus 1 minus yr. This is the general and it keeps on going, right, till yn, right? So in general, I can write this forward differences as, forward differences are the symbol, one second, the symbol delta is called forward difference operator, right? The symbol is called forward difference operator. So in general, how can I write? Just now I showed in R, no? I can write forward del difference operator yr equal to yr plus 1 minus yr. The r value I'll change. R value takes from 0 or 1, check. Since we have x0, y0, I'll write r value equal to 0, 1, 2, so on, right? This is the general definition of the forward difference operator, first forward differences. Similarly, we have next forward differences also. That means if you subtract these, what we have these, if you subtract these, this one, forward delta y1 minus forward delta y0 will be second difference. Forward delta y2, forward delta y1 minus forward delta y0 will be second differences. Similarly, forward delta y2 minus y1, delta y3 minus delta y2, those will be the second order. So how to write that? One second. Before that, we'll write the table so that you will understand easily to write the second forward differences. Okay, first forward differences were forward delta y0, forward delta y1, forward delta y2, so on. These were your first forward differences. Right? So second forward differences will be second forward differences are, how to write second forward differences? Delta y1 minus delta y0, delta y2 minus delta y1, and so on. They are denoted by delta square y0. The second a, if you are writing a minus b, the right hand notation only, right hand term only. Delta square y0, delta square y1, delta square y2, and so on. So shall we see the, so what will be the general term, rth term? Rth term will be delta square yr, right? So it will be, general term will be delta yr plus 1 minus delta yr, and so on. Fine. So second differences, generally I can write it as delta square yr equal to delta yr plus 1 minus delta yr, where r is taking from 0, 1, 2, and so on. Fine. We will see exact value of that now. What is delta square y0? It is delta y1 minus delta y0. Fine. What was delta y1? Delta y1 is y2 minus y1. Yes or no? You will use the notation, this part y1 notation you will use for delta. So you should increase the suffix and write y2 minus y1 minus delta y0 will be minus y0 you will get. One suffix you should increase. So calculate this, what you will get if you calculate. If you calculate, you will get it as y2 minus y1 minus y1 plus y0. So this will be y2 minus 2y1 plus y0. This is the value for delta square y0. So shall we see one more? Delta square y1. What is delta square y1? This is delta y2 minus delta y1, which is equal to, what will be delta y2? You will have subtraction of two terms. The second term is delta y2. What will be the first term? You should increase one suffix in forward differences. What is delta y1? Delta y1 will be subtraction of two terms. Right side term will be delta y1. The previous term, first term will be, you should increase the suffix. Then simplify and write. This is y3 minus y2 minus y2 plus y1. So this answer will be y3 minus 2y2 plus y1. So this is how you find out the delta square values. Fine. Similarly, you will go on doing for how many ever you want. Fine. And what will be the next? This is what second forward differences. What will be the third forward differences? Difference of second forward differences will be third forward differences. Fine. So this is what we have got to know about forward differences. So in general, what is delta power n is referred as nth forward difference operator. Fine. Is defined as nth forward difference operator. So we are done. You got to know what is forward differences, first forward differences, second forward differences. How many ever you want, you keep on doing third, fourth and all forward differences. Right? What it is second term minus first term, that is y1 minus y0, that is forward delta y0. Y2 minus y1, forward delta y1, so on. Right? Shall we make the table for this, for forward difference table? What did we see? We had values of x. Then, one second, I'll draw. We had values of x. Then I had values of y. Then I'll have first differences, forward differences. First forward difference. Then I'll have second forward difference, then third, then fourth, so on. Right? I'll just draw a line for y values also. Right? Now, what were the values we took for x? The values for x were x0, x1, x2, x3 and so on. Last value will be xn. In between you can write xr. Right? So values for corresponding values of y are y0, y1, y2, y3, so on. You will have yn. Last value will be yn. Right? What is first forward difference? What is first forward difference? What is it? It is y1 minus y2. Right? It is y1 minus y2. First forward difference is this term. See here. This y1 minus y2. So I am writing it as y1 minus y0. So what was the notation? Forward delta operator and y0 was the notation. Yes or no? Then what is the next one? Next one I'll do y2 minus y1. So y2 minus y1. What was the notation? Forward delta y1. Between, you should write in between these two, not in the first row, not in the second row. It should be between y0 and y1. The value should be written in between y0 and y1. Right? Next one. Next value I should write in between y3 and y2. So if you use a ruled paper, it will be difficult. Then I'll have the value y3 minus y2. What is the notation? Forward delta y2. So on. Last subtraction will be what? Last subtraction will be yn previously. Between yn minus 1 and yn you will get the value. Between yn minus 1 and yn you will get the value as yn minus yn minus 1. Forward delta yn minus 1 will be there. Now, what about second differences? I should subtract forward delta y1 minus forward delta y0. Then I'll get here as forward delta square. You should write in between these two, you should not write in this line, you should not write in this line, you should write in between. The number of elements in the column keep decreasing. One second. So what is the value here? My value here is, the notation will be delta square y1. Is it? Delta square y0 equal to delta y1 minus delta y0. Next will be, I should write here, I'll get delta square y1 equal to delta y2 minus delta y1. Here I'll get it as next term I'll get. Here it is dot dot dot. Next term I'll get. So similarly, third differences will be, what will be the third differences? Down one minus the above one. That will be delta square y1 minus delta square y0 value. What will be the notation? Delta cube y0. That is the third forward difference. So in this table, since I have done till only y3, till here. See, I have done only till here. Rest all I didn't do. It kept on decreasing and I ended with single term for third difference. If you write for more terms, you keep ending more. See, once I'll show you. So I'll erase this and expand. I'll also correct over here. These are third forward differences. Next you'll get fourth forward differences, then fifth forward differences, and so on. So if I expand the elements over here, suppose I have, this was y3. Suppose I have x4, y4, then x5, y5. What will happen? We'll see how many terms we'll get. First I should do y4 minus y3. y4 minus y3 is my first forward difference and it is represented as delta y3. Here I'll get it as y5 minus y4. It is in between. I'm sorry. In between y4 and y5 you will write it as y5 minus y4. It is nothing but delta y4. Fine. What about second forward differences? You will subtract these two. Delta y3 minus delta y2. That is written over here. You will write in between delta y3 minus delta y2. It is second forward difference of y2. Then you will subtract delta y4 minus delta y3. Delta y4 minus delta y3. It is written as forward delta square, second forward difference of y3. Fine. Now we'll go to the third forward difference. How to do third forward difference? We have done delta square y1 minus delta square y0, which got delta cube y0. Fine. So similarly, if you do delta square y2 minus delta square y1, you will get over here in between these two delta square y2 minus delta square y1. This is third difference, delta cube y1. Then between these two, if you do delta square y3 minus delta square y2, you will get delta square y3 minus delta square y2 is delta cube y2. Then you can go see. Now you have three terms. You can go for the fourth difference. Fourth difference will be delta power 4 y. I'll show you the suffix. What is this? You will subtract delta cube y1. Down 1 minus above 1. That is delta cube y1 minus delta cube y0. Fine. So what will be the suffix? The right hand part will be the suffix delta power 4 y0. Then if you subtract these two, you will get it as delta power 4 y. Tell me the suffix. You will have delta cube y2 minus delta cube y1. What will be suffix? 1. This suffix will be there. Fine. Are we done with my table? No. You should do till you get only single value in a column. That means you will have fifth difference also. What will be the fifth difference? Delta power 5 y. What will be the suffix? Delta power 4 y1 minus delta power 4 y0. Suffix will be not for forward differences. Fine. So this is how you will form a forward difference table. So till now you have only learned to form a forward difference table. You are doing nothing with it. You just framed and calculated the values in the forward difference table. That's it. You didn't find any value. You didn't find. I mean interpolation. I told you will find a y0 particular value with corresponding to the particular x0 xi value, yi value corresponding to the xi value. You didn't find any particular yi value. You didn't do any finding out any value, just calculated and kept all what is needed. This is called forward difference table. Right? I'll just show you what we have done. what we have done, we got to know we have taken equally spaced independent variable, that is x values are equally spaced. We have three finite differences basically, forward, backward and central. We have seen what is forward difference. What is forward difference? First forward difference, then first forward difference, symbols, operator, it is called first forward operator, then second forward differences, then third forward differences, and so on. For delta power n is referred as nth forward difference operator. Then we have seen how to arrange back in the table, right? How to arrange the forward differences in a table. This is what is the table.